accepted.
All right. Good morning, everyone. I hope you're having a great start to Devoxx already, and thank you for being here. I'm Sander Mak, and I've been doing software development for quite a long time now. And at this moment, I'm part of an online grocery scale-up in the Netherlands called Picnic. Before that, I've been doing Java development in IT consultancy for over a decade. And that's all just to say, I've seen some things. And if you're doing software development for a long time, then at some point you start to wonder, what is it actually that we do? What is sort of the nature of our work? Do you recognize this? Do you want to do this as well? Well, maybe now you do. But the more I thought about it, the more I think that what we actually do can be best described as the art of software development. Now, let's not get ahead of ourselves. And I first want to do a quick poll. So raise your hand if you're a software developer. Come on, don't be shy. Very good. If you're a manager, no need to raise your hand. Don't do anything. You're doing just fine. Keep your hand raised. Please keep it raised. Get the blood flowing. All right. So who of you who is a software developer, and by the way, awesome to see so many here, what I would expect at Devoxx, keep your hand raised if you call yourself a software engineer. Almost all of you. Wow, brave. I'm not saying you're wrong, but you might be wrong. Let's find out. Because doing software engineering and being an engineer actually means something. And engineering was a thing already quite a while before we even called something software engineering, right? So we have civil engineering, chemical engineers, electrical engineers, and all of these fields, they're really sort of an applied science. There's a vast body of work that these engineers work to turn their knowledge into actual things that we have in the real world, and they do this following rigorous principles, processes, using science, and making something that is useful for the rest of us. But most of all, a lot of engineering disciplines also have a lot of accountability. Now let me ask you a question. When was the last time you actually signed off on a piece of code that you wrote, certifying that it didn't have any bugs? I didn't. I hope I'm not asked to, actually. When was the last time when you were actually held accountable for the work that you did? Maybe even good sued over it, right? I hope not. But this is what happens if you're in a sort of a regulated space, if you're doing engineering like civil engineers, chemical engineers, and so on and so forth. If you design something, you're liable for it. And it's interesting, right? Because software engineering is, I would say, not quite like that. And they also noticed this in Canada, where at some point a regulator said, okay, guys, it's all very nice what you're doing with software development, but don't call it software engineer or software engineering, because it actually has a meaning. And of course, everyone was up in arms, and we want to call ourselves software engineers, but as we know now, there's actually a little bit of a point here. And if you read this article, it actually says, professional engineers are held to high professional and ethical standards and work in the public interest, it said. The public places a high degree of trust in the profession, and these layers of accountability and transparency help keep Canadians safe. Wow, that's amazing. I want to be an engineer when I read this. But remember, this article is talking about how software engineers are not actually engineers, or at least not in the eyes of this regulator, which is a bit sad if you read between the lines here. So, what if we turn this a little bit around? What if we would think of the civil engineers doing their work a bit more like software developers? So, one engineer comes to another engineer and says, let's build a bridge. Because let's face it, that's sort of the level of requirements that we sometimes get as well as software developers. And of course, the engineer says, sure, I'll give you an MVP in 2 sprints, right? Well, no civil engineer will ever say that, but let's assume. And of course, as software developers, we might not even say 2 sprints because, well, it's done when it's done, right? Anyway, we all know how this will end. It will end in madness. It will end in something that we don't want to walk across. It will be something that this engineer doesn't want to be held accountable for. So all in all, I would say there's a reason why engineering doesn't work like this, right? Like I said, there's a vast body of knowledge, practical knowledge built up, science being done to build a bridge. You can actually calculate things. You want to plan this ahead. You want to do more than just YOLO your way through a bridge. So yeah, that's quite a difference in how we work, I would say. So maybe we should try science. And we have science as well, right? We have computer science. So are we then maybe more computer scientists rather than software engineers? Great question. So I love computer science. I studied it. I think a lot of us studied computer science before becoming software developers. And it's great, right? It's almost like mathematics. There's like these eternal truths. We have data structures, we have algorithms, big O notation. It's all very nice and neat and consistent and cool. So we learn about data structures, graphs. Take, for example, trees. We learned that trees can't have cycles. Super important, very good to know. And then bam, you're in the real world, where trees actually can have cycles, because your product owner comes to you and says, see, trees can have cycles. And there's actually a big gap, I would say, between the sort of things that we learn in our computer science degree versus what we do day to day. Of course, a lot of things are based on this, and we go to it every now and then, but there's a huge gap, and I wouldn't call myself a computer scientist, to be fair. So maybe we haven't really looked at the right example here, because there's other obvious concepts that do have a real importance in the real world. Let's take, for example, recursion. So we all know that to understand recursion, you must first understand recursion, right? But I'm going to assume that we have that down here and going to skip that. So it turns out that recursion is actually super important to understand things in the real world. Take, for example, this article. Hitman hires hitman, who hires hitman, who hires hitman, who hires hitman, who tells the police. Recursion in real life, cool, isn't it? It's got everything. It's got the suspense, it's got the drama, it has recursion, it has the base case. And if you read closely, it's the base case, the termination of recursion is actually one of the hitmen saying, I'm not going to do that for that little money. I'm just going to turn us all in. So again, computer science concepts, they have their application in the real world. And yes, we do use them as software developers. But I would say not too much. So what we do day to day, we use a lot of output from computer science, compilers, the data structures that have been made for us, etc. But we're essentially combining a lot of frameworks, tools, and libraries to create useful software. And that's great, that's good. It just means that we're probably not really computer scientists either. So, of course, there are exceptions. Some of you might work in academia and be actual computer scientists, work on important things like proving P is NP, or maybe the other way around, or P is not NP. I'm not sure what to root for here anyway. But, I mean, sure, you're a computer scientist then. But I think it's safe to say that the most we are busy with computer science as software developers is actually when we're trying to find a new job, right? There's very nice whiteboard and lead code exercises. So all in all, I would say maybe we're not engineers, maybe we're also not fully computer scientists. So what is actually going on then? Now, as software developers, we're always active in some kind of domain, right? It could be anything. It could be e-commerce, could be factory automation, could be building a software as a service application for maybe financial professionals. There's always some domain where we want to solve some problem, right? And then the easy way to think is that, well, then let's just take this computer science and software engineering kind of knowledge, apply it, and then we get great software, right? Easy as that. Well, I'm not sure. Because if that were the case, then we wouldn't have projects that were late, we wouldn't have too many bugs, we wouldn't have these high-profile outages that even affect Google, Atlassian, Datadog, and so on, security breaches. So there's a bit more to this. And what I want to say is that what I believe is what we need is a bit more art, is a bit more gut feeling sometimes also in the work that we do, because we know it's there, right? We know we cannot have this rule book which we just follow and then we get great software. That's not how it works. So I think this piece of art, the art of software development, is even bigger than we give it credit for. So yes, there is engineering in software development. Yes, there is computer science in there. But bringing it all together, making great software, that is actually something that is more of an art than it is a science or than it is an engineering discipline. Now, what this means? Well, it means that you're an artist. Congratulations. That's cool, right? I think it's really cool, because as developers, we're really shaping the world with the code that we write. We create something from nothing. And that's something that not a lot of professions can do. And we can do it over and over, and we can keep improving. It's all so flexible and malleable. And that's cool, right? This gives us infinite possibilities. Unfortunately, I'm not the only one who thinks that developers are actually a bit of an artist, right? So here's a quote from John Romero. It says, "You might not think that programmers are artists, but programming is an extremely creative profession. It's logic-based creativity." And I love this quote because it's sort of this nice tension between logic, creativity, logic-based creativity. It brings it all together. And balancing that, and being good at this, that is the art of software development. Now, of course, I know we don't always create things from scratch. We don't do always novel stuff. And sometimes we practice the dark art of copy-paste driven development, right? I know, I'm guilty of this as well. But I think we should always strive for being the best artists that we can, really creating something new, really creating something that we're proud of, instead of doing this sort of copycat behavior, or copy monkey in this case. All right. But some of you say, "Oh, Sander, you're making me sad. You're making me sound like an amateur. What is this, an artist? I want to be an engineer." And to that I say, what? Do you think artists are not professionals? These guys, they perfect their art. The painters, they practice so hard. And they're not just painting for the painting's sake. All this work that we see in the museums around us, it has been commissioned, it has been paid for. And, well, I hope you are also getting paid to write code. So that means that you're still a professional, right? And we all know what happens when you mix art and amateurs. Remember this one? Yeah, me too. So software development being an art, or at least being for a large part an art, doesn't mean that we're amateurs. It means that it makes our profession maybe a bit more interesting, I would say, maybe a bit more challenging than we thought. So what do we do then as software development? And I would say, if I want to summarize it in one word, is that if we're doing software development, we're actually practicing abstraction. So we're taking something in the real world, and let me, for example, take what we do at Picnic. So we are an online groceries company, so we want to make doing online groceries as fun, easy, and affordable as possible. So that means that we have an app where people can order, and then the next day, these cute electric vehicles, they arrive at your doorstep, they bring your groceries, everyone's happy. But it takes a lot of software to make this happen. Like a lot of software. And we have our own warehouses, we do our own logistics, we have the planning, we have the app, we have the backends that go with that. It's a ton of software. But what we're essentially doing is looking at this problem, at this thing that in the real world that we want to solve, and we're looking at this as artists, and we're trying to paint sort of the picture there, right? And for that to work, we need to abstract, because we cannot automate everything that we see around us. So we need to figure out what are the details that belong into our applications, into our code. What are the good abstractions? What can we leave out? And that is essentially also sort of doing what a painter does, like putting on a particular lens, looking at the world, and creating this abstract and hopefully pleasing picture of it that's useful to people around you, and where art may even drive change, and our software might even drive change in the world around us. Now, in this sense, our IDE is our canvas, and code is our paint. And using this superpower, we can change the world. We can make things better. We can actually solve problems, like real engineers, using code, using software. Now, there's a lot of aspects to this where we get involved. There's this coding, there's testing, there's design of software, there's a process around this. And all of those have a bit of a relation to the software and the art of software development. So let's go over these a bit. Let's first look at code, because in the end, code is truth, right? If you can have the best process, you can have the best design or architecture. If you don't write the right code, then you don't have a product to ship. So what is good code? Here we have the Mona Lisa, of course, widely regarded as one of the most beautiful paintings by Leonardo da Vinci. And why is this such a beautiful painting? Is it the haunting eyes, the elusive smile, the use of color? Well, a lot of that, yeah. But if you look a bit deeper, there's also a few principles here at play. Anyone know this? It's the golden ratio, right? And you see this a lot in art. And it's not as if all art must follow this principle, but a lot of good art actually follows this principle when you analyze it. So this golden ratio is super pleasing to see, also something that occurs in nature and has been sort of put into the principles of doing art. So do we also have a golden ratio of code, maybe? Good question. What would it look like? Something like this? Well, I must admit there's something aesthetically pleasing about Ryu just indenting your code like this. But of course, this is horrible, right? So we don't want code like this. And as a side note, I'm super happy that in Java 21, we're getting Loom and virtual threads to save us a little bit from callback hell, so we don't have to suffer this. But yeah, so maybe we shouldn't really go for a visual metaphor. Because in the end, the source code, the layout, the way it looks, you can think of this as art, like in this submission to the International Obfuscated C contest, but it shouldn't be. A source file is just a source file. It should not be a handcrafted snowflake that people are amazed at and then shouldn't touch and should keep intact, etc. So I'm a big fan of the concept that there's beauty in uniformity when it comes to source code layout. I think the Go programming language really got this right when they actually built in formatting into the compiler, into the language ecosystem. So if you're doing Java development, I would say just bite the bullet and adopt one of these auto-formatters. Make sure it's in your CI, make sure that no code gets merged that doesn't adhere to this formatting, and just stop the drama. Stop the discussions about tabs versus spaces, etc., and start focusing on what really matters. So, yeah, the art of writing good code, we're not talking about sort of the visual layout here. So here's the Mona Lisa again. And why do you think this painting was made? Anyone knows? Actually, there was this guy, Francesco del Giocondo, who asked Leonardo da Vinci to create a pretty picture of his wife, as you do, of course. So that's the reason why it's here. There's a real clear purpose. There's a commission to actually create this painting. And of course, at that point, Leonardo took over, and his art took over, his skill, and he put everything into it to make this one of the best paintings ever. But he didn't create this painting just to practice the golden ratio or whatever, or some other principles. There was a really clear purpose why this was there. And I think the same holds for code. So good code is actually code that solves a real problem, that is useful, and solves it well. And it sounds super obvious, but if you start reviewing pull requests with this in mind, I guarantee you get completely different discussions, and hopefully much more meaningful discussions around why you choose certain abstractions. Are these the best abstractions? Is this really solving a problem that we want to solve, that we need to solve, rather than the discussions around tabs versus spaces and so on. So, second, good code has high quality. And this is something that is, I would say, more subjective. But at the same time, we also feel as software developers that this is super important. Because our code, we might write it once, but it will be read much more often. It will be read by many people. It has to outlive you. It has to have a certain quality to be able to be good code. And finally, good code is code that fits into a context. Nobody likes a guy who comes into a new team and just does everything differently because reasons, right? So good code is mindful of the context and fits into where you are as a team, where you are as a company. And that also means that at the same time, this can evolve, and that's okay, and that there's many different kind of contexts in which different code can be considered good. If you're doing game development, what is good code is completely different than when you're doing enterprise development or microservices or other kinds of development. So again, context is king here. Now, the first and the last, they're quite subjective, but quality we can dive a bit deeper into. Because a lot has been written about quality code. For example, these books, probably a lot of those are familiar to you. And there's a lot to unpack here, right? First thing to notice, at least, is that we're pretty good as software developers at creating acronyms. I'm pretty sure that you know at least a few of them. But there's a lot of principles, and these are really semantic principles, so not about code layout or really nitty-gritty details, but really about what it is to write good code. And don't get me wrong, these are not bad principles, but they're super generic, right? And the question is, which ones do you apply when? And that is a question of subjective quality. That is a question of the art of software development, I would say. And sometimes these are even in tension, right? So sometimes, to keep it simple, you might want to duplicate and modify something, which violates don't repeat yourself. And there's lots of these tensions in these principles that we have here. So it's far too easy to say to someone, just go read clean code and you'll be a better developer. Yes, you'll have some principles now that you can use, but should you use them? And when should you use them? I think that is the big question here. Now, what I would urge you to do as a software developer is to indeed think of this as an art and have these discussions with your team about what is good code, when do we want to apply principles and where, and more importantly, why. But then try to engineer them away as much as possible. So we already saw a trivial example of this with the source code layout, right? You can automate away these discussions by just having this formatter in there and just enforcing it and be done with it. But there's many more places where you can do this. So it makes me really sad when I open a pull request and I see these kind of comments. First one is indeed about formatting. Second one is about using a different API, which indeed is an improvement, but I would say probably not that important to the actual problem that you're solving. And the last one says, well, maybe you should use the overload, which takes an explicit time zone. Yeah, that's typically a mistake that people make. We want to prevent this. So you can have these discussions over and over again. You can have your senior engineers chime in and sort of do this on a rolling basis. But it gets tedious, and it is besides the point of actually solving the problem in the domain that we're interested in, right? So there's lots of tools here that we can use to engineer our own style into the software development cycle. And there's a few here, spot bugs, SonarQube, mostly to actually flag these kind of things. There's error-prone and open rewrite, tools that you can use to actually rewrite code and automatically enforce these kind of style guides and choices and discussions that you have. So there's lots of things that you can do. And just to give you a small example, this is an example of an error-prone template that actually implements this PR comment. And by having this template and enforcing this in your CI pipeline, you will never again see this not optional is empty, which can now be replaced by optional is present. And you don't have to discuss this anytime more, and don't waste time on it in the pull requests. Another example, which is also taken from how we use error-prone at Picnic, you can easily create a so-called bug check in error-prone that finds these invocations of time zones, of time-related APIs, where people forget to actually pass in or use the explicit time zones, which leads to all kinds of issues down the line, and flag this to the user. Now, if you like this kind of stuff, I highly recommend that you go to this talk tomorrow, Automating Away Bugs with Error-Prone in Practice. But the point here is that this is a second step. First, you need to practice the art of software development, come together with your team, and actually discuss these kind of things, see what is important to you, and then engineer the way. And that way, you get to focus on what really matters. Because in the end, these tools, they're not the point. They're tools. We should use them. They should not dictate the way we do development, but we should use them to become better, to become faster, to become more efficient. And we can only do this by not blindly adopting them, but using them in a way that really fits the way that we see software development should be done. So, I mean, can you imagine that Leonardo da Vinci or Vincent van Gogh or some of the other painters were actually debating sort of the brushes that they were using? I can't really. And in the end, if you have a great technique, it doesn't matter. It doesn't matter if you have great tools and if you're a master of the tools, if you don't create inspired and useful work, right? So actually, I can imagine a little bit how it would have been back in the days when Vincent van Gogh was there. So it's roughly the year 1885. And of course, one of the oldest social media, Reddit, was around. So we have this subreddit painting. And this fellow called Van Gogh, the one-ear man, posts a post which says, "Hey guys, I need some advice on which brush to use for my next masterpiece. Any recommendations?" "Sure." Monet, the water lily king, says, "Van Gogh, seriously? Your paintings look like a chaotic mess. Fine brushes provide the finesse and control needed for true artistry." I find fine brushes so boring. I like to use a fan brush to create interesting textures. By the way, notice how Van Gogh doesn't understand threading, but, well, it's 1885, so he's forgiven. And then comes Renard and says, "Well, fan brushes are overrated, Van Gogh. A filbert brush is much better for blending colors." Blah, blah, blah. Oh, come on, Renard. Filbert brushes are too generic. I like brushes that live and live. There's a lot of discussion here, and there's no art. Do you think this leads to pretty pictures, to real paintings, to art? No. So I'm actually pretty happy that there was no Reddit around in 1885. I'm sure there would have been flame wars around brushes and around their technique, etc., etc. There isn't, and there hasn't, and fortunately we get to reap the benefits from that. But what I want to say is that a good craftsman never blames their tools and certainly doesn't obsess over them. So you use the right tool for the right job. Notice I don't say the best tool for the right job, because that also leads to over-analysis and focus too much on tools. You use the right tool, and you actually start solving problems that are worth solving. So if you want to read more about this, I highly recommend going to this boringtechnology.club site. It has an amazing sort of talk on there on how we actually, as developers, are a little bit prone to jumping on bandwagons and jumping on hype trains. And if we can avoid that, we can become much better at the art of software development. And rather than doing resume-driven development, we actually get to solve real problems and deliver real software that makes real people happy. Because in the end, your users, they don't care about your code, right? They care about the value that you deliver, about the products that you ship, about the features that you offer. And of course, as true artists, as true software developers, we care about the quality of a code because we know it's important in the long run. And ultimately, of course, the customers also care about it because we can only keep delivering value if we have actually high quality code. But that is the real art of software development, right? This catch-22 between delivering value, keeping quality, and doing this at a sustainable pace. All right. But like I said, software development is more than just coding, right? So what about testing, for example? Now, testing, some people think that testing is about proving that a system works. It isn't. It's impossible. Testing is about finding all the ways that we can break a program. So it's a form of, I would say, creative destruction. And of course, the most prominent form of creative destruction is doing sort of exploratory testing, right? As developers, I don't think we do this enough, but there's lots of testers who still do this, and it's really cool to see. So they're meshing around your application, trying things out, trying weird things, and then suddenly something breaks, and you see this big smile, and they're happy because, well, they broke your system. And of course, they take a screenshot. Well, maybe not as dramatic as this. But anyway, they provide it to the dev team, and it's up to you to solve. So that's really, I would say, definitely a creative part of software development. But of course, we are developers, so maybe we should focus a bit more on unit testing and writing code to test our applications. Now, what is a good test? I hope we can all sort of agree that a good test sort of follows this pattern, where you first arrange something, then you act upon your system and the test, and then you assert, right? Telling nothing new here, I would say. But looking at this, we know that a test indeed should always have an assert. Or maybe it should have multiple, but at least it shouldn't have 0. And whether you want to be the school that says only one assert per test or multiple asserts per test, that's definitely a discussion that you should have with your team and that you should settle. And then, of course, the question also becomes, do I use these built-in assertions, or do I go for a richer library like AssertJ to actually maybe improve my tests here? And these are all good discussions to have. But again, find your style and engineer the way. These things can be easily also checked, enforced, encouraged by the tools that I mentioned before as well. But as you go up the stack, so to say, of this kind of unit test, you get more and more to trade-offs and an art. So here, we actually want our tests to drive also the design, especially if you do test-driven development. A test should also be a way to actually shape your APIs and to shape the code that you're writing. So then you get questions like, is this test maybe even over-constraining my solution, right? Because it can also happen that you're testing a little bit too much and making your life much harder later on if you want to refactor and you actually break everything that you thought you shouldn't break. Or have we covered enough? And of course we say, well, then we have code coverage, but we all know that 100% code coverage doesn't necessarily say anything. So there's a lot of art, I would say, and trade-offs going on in writing really good tests. And then we get to sort of the arrange. So we want to have understandable and maintainable tests. That raises the question, should we mock? Shouldn't we mock? Should we share data between tests? Should we keep everything to a single test and set it up over and over again? And I'm not going to answer these questions for you because, again, context is king here. And this is really a discussion that we should have as software developers with our teams. And this is something where we can actually practice the art of software development and make these trade-offs together. So this is definitely more of an art than it is engineering in the end. So moving on a little bit from coding to testing to design and architecture, right? And some people are thinking, right, do we even need this stuff, right? I mean, I thought it was more like quite a while ago, because in this case, it feels like the pendulum has swung a little bit in the other direction. We're maybe doing a little bit too much art if we look at software architecture, right? So I present to you the software architecture art in, let's say, late 20th century, early 21st century style. Boxes and arrows, easily recognizable. I think this is all pretty common for us to see and think, well, I don't know if this is actually useful, right? Let us just code. We're agile now, we just write the code, we go ahead. If it doesn't work, we'll try something else. And that's not a novel thought. Actually, Martin Fowler wrote this Is Design Dead article in 2004 when Agile was coming up and XP and all this stuff. And a spoiler alert, answer is no, at least according to Martin Fowler. And also according to me, I think there's still a right place to do design, to do architecture in your software development process. Because you want to ensure that you're building the right thing. And it is all too easy to make costly mistakes when you don't think ahead. And there's lots of risks and assumptions that are left implicit if you only keep iterating and iterating and iterating in sprints and in cycles. And in the end, like with code, a system will outlive you. So some form of documentation and some form of knowledge sharing is actually quite beneficial. And doing design and doing architecture is a great way to actually build this up. Now, I'm not sure if we actually need a role to do this, like an architect who sits there in the big tower and says, this is how we're going to do it. It's more of a responsibility, but it needs to happen, even if you do it with a team. And I believe that every senior developer should be able to do this, should be able to design a system, create documentation, take others along, make sure that you don't make mistakes that are super hard and super expensive to fix later. Because a wise man once said, weeks of coding can save you hours of designing, right? I think that sort of sums it up. Now, last year, here at Devoxx, there was a talk by Simon Brown called The Lost Art of Software Design. Well, you can see how I like this title, of course. And it's a fantastic talk. I highly recommend checking this out if you want to dive even deeper on this topic. Because it is, I would say, one of the more daunting parts of our software development cycle. Code is comfortable, right? We all know how to open our IDEs and how to get cracking and write some code. But getting to a good design, that's actually pretty hard. Why? Well, there's no compiler that corrects you. There's no very fast feedback loop with tests, etc. It's much more wishy-washy. It's much harder to actually create good designs, communicate them, really understand the problem, be clear about all the trade-offs that you're making, because design and architecture, they're always about trade-offs. There's never a perfect solution here. And in the end, design is communication, and communication involves people. Well, people are hard, so ergo, design is hard. So what can we do? I think there should be one driving force across design. And we cannot go super deep, of course, but this driving force, to me, is simplify. What do you mean by that? Well, maybe you've seen this quote by Pascal, where he said, if I had more time, I would have written a shorter letter. So if we translate this to architecture, it might sound like, if only I had more time, I would have created a simpler architecture. Said no software developer ever, of course. Yeah, I'm afraid so. So why is this? Why do we love complexity so much? Why do we keep making more and more complex designs and things? Why is it so hard to simplify? I thought a lot about this, and then at some point, I noticed this article in Nature, and it turns out we actually have a little bug in our brain. If we want to solve problems, it turns out that we like adding stuff. So they presented this problem to people, where they actually had to fix this Lego tower, had to make it stable, and people suggested, well, just add 3 pieces, right? And it's stable again. Yes, but what about just removing this one piece? Would have been much easier, right? Much cheaper, much faster. So sometimes it is not about what we're adding, but it's about what we're taking away. So this is one little hack I want to give you if you're doing design, if you're thinking about architecture. Don't think about what you will add, but also think about what you will take away. And to take it to the artist metaphor, think like a sculptor, right? So you're done when there's nothing left to take away, and you have something that you actually want to have, that's useful, that solves your problem. And this might mean that even if you're introducing or designing a new feature, you should look very hard and careful at your current system and think about, can I not reuse parts? Or can I not remove parts and introduce a new abstraction that actually makes it better for the whole system? So I know this is all very abstract. That's the nature of design and architecture, but still super important, and I think definitely part of the art of software development. Now, doing software design, like I said, it's also about communication. So I think there's another art form that we can learn from called storytelling, which is really also about bringing structure to a story and communicating complex ideas, visualizing it, taking people along with you. Because in the end, you can create a great design, but if no one reads it, if no one implements it, nothing happens, right? So if you're writing design documents, or RFCs, or architecture decision records, or whatever system you use in your company to document these, then storytelling is something that really will benefit you, because it will help you communicate, it will help you convince people to follow you, to work with you. And of course, you do need a story to tell, right? And for that, there's the old and trusted domain-driven design, and the somewhat newer event storming that you can apply to actually uncover the story that you have, to find sort of what has to happen in your system, but then you describe it. So how do you get better at this? Practice. And we don't do this a lot. In coding, we have this thing like code katas, that people sometimes do. What I started with within our company is actually giving a workshop on software design and architecture. And one part of this workshop is actually creating a design document for a fictional feature, which I thought up, and then just working in groups to create an RFC, to write a design document for this feature. And you wouldn't know how interesting this is. If you do this with 5 groups, and they each come up with their own design, you can discuss the trade-offs, you can learn from each other. I would highly recommend doing this. It's a great way to actually get better at design and architecture, if you want that. All right, so that was design. So we're left with process, right? Our favorite part of software development. Or is it done yet? Yeah, no, probably not. So process. Here we have the opposite problem with architecture and design. Some people think this is a solved problem. Here you see this ISO standard around software engineering process. You even have to pay for the privilege of reading it. Spoiler alert, I didn't pay, but I did read the introduction. It wasn't great. So yeah, of course, this is not the answer. This gives an illusion of control, and there's more, there's safe, there's less. A lot of illusion of control going on. And in the end, I think agile is nature's way of telling us that software development isn't strictly an engineering discipline. We cannot make this whole plan up front for the rest of the year and make it happen. That's just not how it works. But I mean, agile, there's also a spectrum there, right? So on the one hand, you have the sort of take it as you go approach, spec by slack, I call it. So you get a message and you implement it, and next day you get another message and you implement it. It's horrible. But equally horrible is the whole Scrum-full kind of approach where you make it look like you're doing Scrum. You have all the ceremonies, but you're still doing full-on quarterly, yearly planning, tying everything down. So there's a lot of issues with this. And I know you're all hoping here for me to get this brilliant insight from Art and how we can tackle this software development process. I'm sorry, there's no silver bullet. Still not there, never has been, probably never will be. What I can do is I can turn this a little bit around. So what I want to say is that maybe we shouldn't focus so much on the process, but we should focus more on our teams, on our own behavior, on what we do, influence what we can influence around us. So there's a few things that we can do as developers while practicing the art of software development. And that is be very explicit about the expectations that you have towards your teammates, but also towards the outside of the world. So many things go wrong because we don't communicate well. So once we start doing that, things do become better. We also want to be as autonomous as possible, right? We always love to have autonomous teams, but it means that you actually need to earn the trust. Do what you promise, deliver what you promise, don't overpromise. Also give this trust to others. And as we keep doing this, you will see that process starts to matter less. And the one thing that really helps every team is being a continuous learner, being curious, the word that we heard at the beginning. So this is really something that will help every team in whatever situation you're in. Because I firmly believe that great teams that do this, it doesn't matter if they have a bad process. Sure, it's not nice, but you'll survive. You'll get there. You can evolve great processes. But if you're not gelled as a team, if you're not doing these things, then you can have a great process, but you still will not deliver your best work. So if you want to read any book about software development, don't read the Scrum book. Don't read too much about process. Read this peopleware book. Because in the end, software development, it's the work of people, right? And if we want to get better at this, we need to get better at these things, at empathy, at working together. And then the process will follow. All right, so wrapping up, how do we learn this stuff? Because I call this the art of software development. I talked about how most of us studied computer science. Isn't that enough? Or is it just experience to get better at this and to actually become this software artist? Well, I think a lot of us turn this question into the question of how do you get the right knowledge? So who here has these books on the shelves? Not too many? Well, I do. I'm not too afraid to admit that I have not read all of it, only just a very small part of it. I can also tell you that if you read this cover to cover, if you've studied computer science, you start your first job, you will not be able to write great software. You have a lot of knowledge, but there's something lacking here. So maybe we should talk about skills. And you know, I'm Dutch, so I know how to ride a bike. Not everyone does, I do. And that's a skill. That's also something that you don't learn from a book, right? Well, apparently there's actually a book that's called Bicycle Riding 101. I first thought it was a joke, but it's actually a book that exists. I was so close to buying it because I'm really, really interested in what's in there. What does it say? Does it say, like, just get on and pedal and keep going, try not to fall? I don't know. Anyway, we all feel sort of that this doesn't work. You can't learn this from a book. And then you say, okay, maybe we need something more rigorous. To which I give you this very fine piece called Bicycle by Bartosz Ciechanowski. And there's like 15,000 words explaining in great detail what happens when you're on a bike, all the forces that are there. It's a great read, by the way. It's fascinating. It shows you why a bicycle works. But still, even after reading this, you will not be able to ride a bike for even a minute. So what is missing here? What's missing is that these skills, they're not just pure knowledge. They're not pure craft. There's this notion of metis, which means wisdom or skill or craft or something, at least, that you cannot learn from books. And if you read Seeing Like a State, which is a fantastic book, which also introduces this concept, it says, this metis, it resists simplification into the deductive principles, which can be successfully transmitted through book learning. Because the environments in which it is exercised are so complex and non-repeatable that formal procedures are impossible to apply. Well, this is sounding like software development, right? We do a lot of new work, new technologies, new stuff, always kind of a different approach, so we can't rely on book knowledge to get here. So what do we need to do? I think we need to also look at how the artists of old actually learned their craft. So these people, they got together in guilds. They had apprenticeships, they had masters and apprentices working together, transferring their skills, actually doing their work together. And this worked great. I think this is fantastic. It doesn't really replace books and formal learning, but it's a necessary component to actually becoming a great software developer. And you also see this in this article there. This is a shift that is happening around us. And to make this very practical, so what we did, for example, within Picnic, is we created our own tech academy where we try to employ this concept, where we hire people right out of university. And that's scary, right? A lot of companies don't really dare to do that. But we said, we're going to put you in a team from day one. But not just to sink and swim, but 50% of the time you'll be working, 50% of the time you get to learn. And this learning happens in multiple ways. So we always assign a mentor, which is sort of the master and apprentice that I talked about. And this mentor, they will pair program. They will have discussions on technology. They will really latch onto what their apprentice needs. And there's a lot of time for this reserved to actually make this work. Next to that, we do have some formal learning. So we have some courses with some experts. We have also access to books, online courses, other things like that. And people actually get the time to do this. And this turns out to be a fantastic way to onboard new people into the art of software development. Because again, you cannot rely just on the education that people have right out of university. There's great knowledge in there, but it's not all you need to build great software. All right, so what can you do? Well, I would say find a mentor and be a mentor. So whatever level you're at, there's always someone you can learn from. Just ask them. Just try to make sure that you're growing as well, but also make sure that you look around you and that you look to the next generation and see what it is that you can do to help them. And this can be in your company, but it can also be wider in your community. Maybe there's a Java user group. Maybe there's other user groups around you, other communities where you can do this. This is a great way to actually spread the art of software development. Because in the end, real artists leave a legacy. So I highly want to encourage you to think about what you're working on. Does it actually matter to you? Right? And that's not something that we think about often, but I think it's really, really important, because if you work on what matters to you, you're naturally also more motivated, you're learning more, you're growing faster. And sometimes you need a little bit of a wake-up call. So this can be your wake-up call, right? Are you actually doing something that matters to you? Are you doing something that makes you happy? Because that will, in the end, matter for your legacy. And this craftsmanship, all of the things that we talked about, do it with a purpose. Don't just blindly apply tools. Don't just blindly apply technologies. Think about how it will solve the problems that you see around you, how it will solve the things that are actually important to your users, to the systems that you're building, and in that way grow as a craftsman. And then in the end, like I said, sharing and mentoring is a great way to bring this forward. And we all have this sort of notion of becoming a 10x developer, right? I think that's not something that we should aspire to. But what you can aspire to is to, over the course of your career, mentor 10 people, and maybe even bring them 10% farther than they could have come alone. And that way, you're that 10x developer. Just spread out over multiple people, and in a way that's much more sustainable. So, leaving a legacy is nice. I do hope that we get some recognition before we die, unlike some of the painters that we talked about, but I think we should be fine there. So this conference is now starting. There's a lot of cool new tech, and I highly encourage you to geek out, to dive into it. But I also want to plant this question in there, this curiosity that we talked about. Don't just let it be about the tools, about the technologies, but really think about what does this mean for my craft, for my art of software development. How can I apply this? And if you want to read more about how we do this at Picnic, there's our engineering blog. Highly encourage you to look at it as well. But for now, I want to leave you with this, and I want to say, go forth and write some beautiful code. Thank you.